Now we're going to look at how we create confidence intervals. And the first one we're going to do is how to create a confidence interval for a population mean. Creating a confidence interval requires that we calculate this t-multiple that we had called before, and the standard error for the sample mean, as well as understanding our desired confidence level. The confidence level is the desired confidence required for the population mean to lie within. So for example, we want a 95% confidence level or a 90% confidence level. Our formula is given by the following. It's the x bar, which is our sample mean, plus or minus the t-multiple times the standard error of the sample mean. So again, if you recall from before, we had our graph that showed our point estimate, which is in this case, it's the sample mean, which is x bar, and then the upper bound and lower bound is going to be created by this t-multiple times the standard error of the sample mean. Now remember that our standard error can be replaced by the following. The sample standard deviation divided by the square root of n, which is the number of observations. Our t-values, the t-multiple, is calculated in Excel using the t.inv.2t function for two-tailed. Since we're looking for a confidence interval that is above and below the mean, we're going to have a two-tailed probability, the probability of it being in the upper tail or the lower tail. Since the confidence level is 95%, we're looking for the probability of 1 minus 95%, or 5% in the two tails. And we're going to use that for the Excel function. So therefore, we would use the following. t.inv.2t for the two-tail with a 0.05 area and the number of degrees of freedom. So let's take a look and see how this works. Let's say on the right we have this data set which has 50 test scores. We're only showing 20, however. We calculate the mean and standard deviation, and we know how to do that using the average and standard deviation.s function. We'll calculate the standard error, and we're going to use the given confidence level of 95%. Now, we'll do the t-multiple first. And so we said that since our confidence level is 95%, we are looking for the area under 5% of the curve at two tails. So it's going to be 0.025 on one side and 0.025 on the other, giving us 5%. And since the total test scores is 50, we're going to use the degrees of freedom of 49, n minus 1. So remember that the standard error is the sample standard deviation divided by the square root of n. So this is going to give us the following. 84.38, which is our x bar, plus or minus the t-multiple that we had calculated, which is 2.010, using the Excel function. And then we multiply that piece by 9.899, which is the standard deviation, divided by the square root of 50. And this will give us the confidence interval of 81.57 to 87.19. So remember that our x bar was 84.38, and it lies in the middle of this. So it gives us the range of a lower bound of 81.57 and an upper bound of 87.19.